Question 1. Find with respect to x derivative of sine x over 1 minus cos x. So this, let's take it as a function. Let's call it y. Let's say y equals to sine x over 1 minus cos x. So this is a function itself. Let's call it u. This other function, let's call it v. So if you recall the quotient rule, if y equals to u over v, where u and v are both function of x, then the y dx, the gradient of the function, is v du dx minus u dv dx over what? Over v squared. From here, u is sine x and v is 1 minus cos x. Now let's look for du dx. What is du dx from here? Cos x. If you differentiate sine, you get cos. From here, dv dx becomes, if you differentiate 1, 0. We have minus here. Then if you differentiate cos x, you get minus sine x. Minus with minus gives plus. So from here, it means the dv dx is actually sine x. So coming back here, so it means dy dx equals to v. What's our v? Then du dx. What is du dx from here? There we have minus u. What is u?
Sine x.
What is dv dx?
Sine x.
Over v squared. So this is the answer, but we can simplify. From here, if you expand, that will be cos x minus cos square x minus sine square x over 1 minus cos x all squared. Cos x. Minus is common here. Minus cos square x plus sine square x over 1 minus cos x all squared. If you recall, one of the basic identities of trig is sine square x plus cos square x is always 1. So we can write it as cos x minus 1 over 1 minus cos x all squared. The numerator is the negative of the denominator. We can rewrite this as minus 1 minus cos x. If you expand this, you should get this over 1 minus cos x all squared. So this here one, and it comes one of these. So the final answer is minus 1 over 1 minus cos x. So therefore, dy dx equals to minus 1 over 1 minus cos x. Is that understood?
Yes.
For this question, if log to base e of 1 over x is y, if y is this, find dy dx. So first, we should know that log base e is also written as this symbol. So if what you have here is x, what will be x. So I can write the equation as y, let's write as log base e of x is power minus 1. So the minus supposed to be back, minus log to base e. About what you have here, you can write it as minus 1 into log x base e. What is log x base e from here? In x. So we're going to write this one here. So normally, anytime we have y equals to ln e, or ln x rather, dy dx equals to 1 over x. Then from here directly, you can just say dy dx. This minus is just a constant. So when you differentiate ln x, you get 1 over x. So that was the final answer. Question 3 here. Find the differential coefficient of this at point 1 minus 1. That is when x is 1 and y is minus 1. Find the coefficient, the differential coefficient. So let's look for the derivative. Here, solution y equals to minus 5 over x squared plus 4. Let this one be u and this one be v. So if u equals to minus 5, du dx will be 0. If v equals to x squared plus 4, the v dx will be 2x. So using quotient rule, y equals to v du dx minus u
the
v dx over,
v squared.
from there it means y equals to, what is v? What is du dx? Minus what is u? What is the v dx? What is v? Sorry, this is now the y dx. From here, the y dx 0. Minus minus plus 5 times 2, 10. So we have 10x. So at point x equals 1, what will be the gradient? So from here it means the y dx equals 2. When we put 1 here, 10 times 1 is 10. 1 squared 1 plus 4, 5. 5 squared, 25. So in decimal or in fraction, that is 2 over . For question 4, if the y dx, or find the y dx if y equals to log tan 2x base e. Solution. We can write this one as y equals to ln tan 2x. As you can see, tan is a function of 2x. 2x itself is a function of x. Tan is a function of 2x. This ln is function of tan. So that's like function of a function of a function. So what can we do here? We can let the whole of this one to be u. Let tan 2x equals to u, or let u equals to tan 2x. From there, it means our y becomes what? U. You can easily get the y du from here. Then can we get the u dx? We know that when we differentiate tan, anytime we differentiate tan with respect to x, it gives us x squared x. But we are not having tan x, so we have tan 2x. So this itself is another function. So here, let w or let v equals to 2x. In that case, it implies that u equals to tan v. So here we can look for du dv. So from here it means du dv equals to what? Sec square v. Is that got in? Then from here, since v is 2x, we can look for dv dx. Dv dx from here equals to what straight? 2. And then from here, y is ln u. We can look for dy du. Dy du is definitely equals to 1 over u. It's not x because it's u. I mean, that's y equals to x, you say 1 over x. Since y is ln, you say 1 over u. Our aim, note, is to get dy dx. Dy dx. So we have to start with dy with something. We start with dy du. Then times du dv times what? Dv dx. It's as though this du will take this one away, this dv will take this away, and at the end we let it what? Dy dx. So therefore from here dy dx becomes, what is dy du? 1 over u. What is the u dv?
Square V.
Z square v. What is dv du? 2. So we can say dy dx, sorry, dv dx. So dy dx equals to 2 over u z square v. Well, in the question, there is no u nor v. So you have to replace back what they are represented with. So 2, what's our u? 2x z square. What is v? 2x. Although we are done, but we can still simplify because tan and sec, they have a relationship. Although we could have ended it by saying dy dx equals to 2z squared 2x over tan 2x. But sec is 1 over cos and tan is sine over cos. If we simplify further, we get a simplified answer. Now, let's simplify it. So from here we can say dy dx equals to 2, sec is the inverse of cos. So we can write as 1 over cos 2x all squared. Then divided by tan is what? Sin x over cos x. In this case, 2. So we can write this as 2, or from here we can say dy dx equals to 2 over cos 2x, cos square 2x times, this cos will go up, cos 2x over sin 2x. So here, cos square 2x means cos 2x times cos 2x. So this one will take one of them, then this square will go away. So from here, I will have dy dx equals to 2 over sin 2x cos 2x sin x cos x. And in fact, you can still simplify this further. Why? Because we know that 2 sin theta cos theta equals to sin 2 theta. Right? Sorry, this is meant to be 2x. Now, still on this identity, let's multiply both by half. So we can say half sin 2 theta equals to sin theta cos theta. So because here we can come back and say dy dx equals to 2 over, so sin theta cos theta is what? Half sin 2 theta, meaning we put half here, sin 2 twice of the angle they both carry 2x. So twice of 2x is what? 4x. Then this half is simple as sin 4x over 2. The 2 go over 4 up there. So from here, let's bring this one back here. So you can say dy dx equals to 2 times 2, 4 over sin 4x. And finally, we can write it as 4 times 1 over sin 4x. 1 over sin is cosec. So from here, it means dy dx is 4 cosec 4x. Final answer. If this question is to be objective, you might not see this in the option, nor this, because this is just simplification. So what we have here, from here, we can just stop here. We can simplify this one as 2 times 1 over sin 2x times 1 over cos 2x. So using this outside with 2, 1 over sin is cosec. Cosec 2x. 1 over cos is what? Sec 2x. So our dy dx can also be this. 2 cosec 2x sec 2x, or 4 cosec 4x or this without further simplification. So any of this is the same. They are all the same. Or from here directly, we can just say from here, this is 2 times 1 over tan 2x, then sec square 2x. 1 over tan is cot, so the answer can also be 2 cot 2x sec square 2x. So this answer is the same as this, is the same as this, and is the same as this one. So this can be written in 3 forms. 1, 2, 3. But out of these 3 forms, this is the most simplified. Because here we have only one function, cosec. Here we have 2 functions, sec and cosec, but they don't have square. This one we have 2 functions, but one carries square. So this is most simplified, followed by this. This is the least simplified, and this is the unsimplified answer. So any of it, you should know how to manipulate. Because for objective question, if you solve, you might not see the correct answer there. Whereas the correct answer is there in another form. So you must learn how to manipulate. Now for the 3 functions we have on the board, 5a, b, c, we have to get the derivative, or you can say the gradient of the function. So from here directly, the y dx equals to, whenever you differentiate cos, you get what? Minus sine x. Let me take this minus outside. So for this x sine x, this actually product rule. This x is u, and this sine x is what? V. So here is as though we have y equals to uv. So for y equals to uv, the y dx is what? U dv dx plus v du dx for product rule. Meaning, leave the first, differentiate the second, which is v, plus leave the second, differentiate the first, u. So leave the first x, differentiate the second, differentiate sine x, that's cos x. Then plus leave the second, sine x, differentiate the first, 1. That's the answer. You can simplify further. So this is minus sine x minus x cos x minus sine x. Minus sine x minus sine x, minus what? 2 sine x minus x cos x. So minus is common, we can factorize the minus out. And from there we can say the y dx equals to minus 2 sine x plus x cos x as the final answer. For this question B, we have product rule. 2x is a function. The whole of this is another function. Now this function, this second one is function of a function of a function. Because the whole of this can be a function. So we now have this limb as a function of another function. So although I will try to use a simplified approach to get it, we are going to use chain rule without using much space. So first, please look up. So it's not too complex. Directly, I will say the y dx equals to, using function of a function, this 2x, let's call it u, and the whole of this, let's call it what? V. So using product rule, leave the first 2x, then differentiate the second, plus leave the second, differentiate the first. The first is 2x, so differentiate 2x, 2. So this part is done. The difficult part is this: how can we differentiate this? So note that we can write this one as lim x squared plus 5. Normally, if what you have here is only x, what we have is let's suppose we only have in x, dy dx is what? 1 over x. But now that we are having x squared plus 5, dy dx is 1 over x squared plus 5. But there's a problem here. What we have here is not just x. So anytime you have function and function, which is chain rule, after you differentiate the whole, assuming that this is just a single parameter like x, then you now multiply your answer by the differential of the inside. Now if you differentiate x squared plus 5, the answer is 2x. So differentiate the whole, which is what? 1 over x squared plus 5 times differentiate the inside, 2x. Before I continue, let's make reference to the question 4 we did. For this question, we can avoid all this step and jump here directly. From here, we can jump here directly. How? This is all I will do. Differentiate the whole. So we have this one just x, so the answer is 1 over times 2x. Times differentiate the inside. So if you differentiate times 2x, that's what? x squared 2x. Now differentiate 2x itself, 2. Come here directly. As you can see. Then simplify. 2 lines, you finish it. Although, if the question is theory, you have to do it this way. But if it's objectives, for objective question, no one wants to check your step. No one is interested in your step. So you can just use directly. Now let's go back to question 5b. Now, what we did is, we differentiated the whole, that will be 1 over this, times differentiate the inside, 2x. Then we can continue the simplification. 2x times 1 times 2x is 4x squared over x squared plus 5. Plus, these 2 will come to the back here. 2 log x squared plus 5 base a. That's the final answer. Let me re-explain. This is u. Everything here is v. So if we have uv, if y equals to uv, dy dx is u dv dx from product rule plus v du dx. Meaning, you leave the first, you differentiate the second. Then you leave the second, differentiate the first. So, leave the first, this is it. Differentiate the second. When you differentiate this, you get this. And how do we do that? For lim or log base e, when you differentiate, the answer is 1 over what you have here. But since what you have here is not just x, we have to multiply by the differential of what we have here, which is 2x. Plus, leave the second one, differentiate the first. If you differentiate 2x, you get x. And that's it. Final answer. Now, question C. What to get the y dx? This is also product rule. Let this ex be u. Let this tan x be v. So apply same rule here. Leave the first, e raised to minus 1. Differentiate the second. If you differentiate tan x, you get what? Plus, leave the second, tan x. Differentiate the first. If y is e raised to x, dy dx equals to e raised to x. So if you differentiate e raised to minus x, the answer is still e raised to minus x. But if you notice what we have is not x, it is minus x. You now multiply by differentiate minus x itself, minus 1. So this is gone e raised to minus x, x squared x. This minus will affect this one, minus e raised to minus x tan x. So e raised to minus x is common. So this becomes e raised to minus x into x squared x minus tan x. Our answer. Although we can still simplify this one. Cos x squared x is 1 over cos square x. This is sine over x. So we can simplify further to get a more simplified answer.